Hello everyone, welcome to our first lesson on chapter 12. We're talking about three-dimensional figures today. Everything that we've been talking about so far in geometry has been two-dimensional. Now we're on to three-dimensional figures. They're called polyhedron. Polyhedrons are solids with all flat surfaces that enclose a single region of space. So several parts of polyhedrons. We have faces. Faces are the flat surfaces. Those are the shapes that we've been talking about in the past few chapters. So we call those faces of the polyhedron. The edges are where two faces come together. So where this face on the front and where this face on the side meet, it meets in a line. That's where those two planes intersect. That line is called an edge. So of course there are several edges on these polyhedrons. And then the vertices, or each vertex, is where two edges meet, or where two lines intersect. We call that a point, and all these points on polyhedrons are called vertices, or one is called a vertex. A prism is a polyhedron with two parallel faces called bases. So there's several specific kinds of prisms, but if there's sometimes it's called like the top and the bottom, the bases, if they're parallel, and they are congruent, parallel congruent faces called bases. A regular prism is a prism with regular polygons as bases. So we got to be specific when we name a prism. This one right here is a prism, but we name a prism by its base. So the base, the two parallel faces here, is a triangle here and a triangle there. So we would call that a triangular prism. In the same way, a rectangular prism is a prism where the parallel faces are rectangles. So this rectangle and this rectangle. And then the pentagonal prism, of course, has the bases being pentagons. So this pentagon right here and this pentagon on the back side are parallel. Okay? And they are congruent. So it's a pentagonal prism. Next shape is a pyramid. A pyramid is a polyhedron with all faces except one intersecting at the vertex. The only face that does not intersect at the vertex is the base. And again, we name a pyramid by its base. We don't just call this a pyramid. We say that the base is a triangle, so we call it a triangular pyramid. In the same way, we don't call this simply and only a pyramid. We call it a rectangular pyramid because it has a rectangle base. And then the third one here is a pentagonal pyramid. There's more. We could have a hexagonal pyramid. We could have an octagonal pyramid. We could have a dodecagonal pyramid. So there's many different types of pyramids, all depending on what shape the base is. Regular polyhedron are polyhedron with all faces that are regular and congruent. So regular polygons, all sides congruent, all angles congruent. Now a regular polyhedron is a three-dimensional regular shape. So a polyhedron with all faces that are regular and congruent. The Platonic solids, named after Plato, who discovered them, they are convex regular polyhedra. There are 5 of them. There is the tetrahedron. This tet right here, or tetra, that means 4. So the tetrahedron has 4 regular triangles. The hexahedron, hex means 6. Sometimes we more so refer to this as the cube. It has 6 congruent sides. Like a dice has 6 congruent sides. We'd call that a hexahedron in geometry. Oct, you guys know what oct means, I think. Oct means 8. So an octahedron has 8 triangles. The hexahedron has 6 squares, octahedron 8 triangles. The dodecahedron, deca means 10 and do means 2. So a dodecagon is a 12-sided figure. 12 regular pentagons make up the dodecahedron. And then the icasa means 20. So the icosahedron has 20 congruent triangles that make up that polyhedron. And those are the 5 Platonic solids: tetrahedron, hexahedron, octahedron, dodecahedron, and icosahedron. Few more three-dimensional figures. These ones are not polyhedron because polyhedron has to have all flat surfaces as their faces. These ones are more of our rounded figures. So the cylinder, a three-dimensional figure with parallel circular bases. A cone is a three-dimensional figure with one circular base and one vertex. and a sphere is a set of all points in space equidistant from one point. You'll kind of notice some similarities as we go through this chapter between the between the cylinder and the prisms, and between the cone and the pyramids. So you'll discover those as we go on in this chapter. And then the cross-section. What a cross-section is it's the two-dimensional shape that is created when a three-dimensional shape is cut by a plane. So pretend you're a lumberjack right here, and let's say you cut this log like this. So what shape would show up as you would look at it? You would see a circle, wouldn't you? This red dotted line that's on there would be a circle if you could look down on top of it from a bird's eye view. If you took your axe and you cut it along a diagonal like this, you wouldn't see a circle, but rather you would kind of see an oval, right? So this one would be an oval, or sometimes a more math word, we would call it an ellipse. And then this one, if the lumberjack were to slice it with his axe right down the middle, this figure would be a rectangle. The cross section would be a rectangle. Okay, so our only example problem for today, mostly terminology, but our example problem, identify each solid, name the bases, faces, edges, and vertices. So this thing is walking down the street. You're going to call it by its name. What would you call it? Don't call it just a pyramid. A pyramid is not specific enough. You name a pyramid by its base. So what shape is the base? This base right here is a rectangle. Some might say it's a square. We don't know that all the sides are congruent, but we do know all the angles are 90, so we would call it a rectangular, and now I didn't leave myself enough room. Okay, a rectangular pyramid is its name. The bases in a pyramid, there's only one base, so I guess it's just base. The base is like a rectangle, so we would label a rectangle like this, rectangle A, B, C, D. A, B, C, D. There's our base. Faces, there is 5 faces. There's 4 triangles that go around the pyramid, and then there's 1 base. So we could repeat the base again, because the base is a face. It's rectangle A, B, C, D. And then we have 4 different triangles. Triangles AEB on the front. AEB is this one on the front. Triangle BEC on the right side. Triangle BEC is on the right side. On the back side is EDC. Triangle EDC. And then there's one more on the left side, and the triangle on the left side is EDA. EDA. Now we have to list all of the edges. So the edges are all line segments. So going around the base, AB, BC, CD, DA. Those are 4 of the segments. AB, BC, segment CD, and segment DA. And then we have 4 more edges where 2 planes come together or 2 faces come together. It's the ones that meet at the vertex E. So EB, as well as EA, as well as EC. And these are all segments as well. And segment ED. Whew! All right, there is all of our edges where 2 faces meet. And our last one is labeling all of the vertices. So where 2 edges meet. Where 2 edges meet, yep. So EA, B, C, D, and our vertex at the top, E. There we have it, A, B, C, D, and E. All right, hopefully that made sense. Review these terms because we're going to be using them a lot in this chapter.